the solution for this example, first thing we need to do is work out our growth on the opening balance. So what we're going to do is here is we're going to say equals whatever the opening balance is multiplied by our net return expected. Putting my dollar signs. I'm going to copy and paste it down. The second is the savings on the growth on our current savings, so how much we put in each year. So we're going to assume that it's evenly put in through the year. So we're going to say take the current savings, multiply it by expected return with the dollar signs on, but divided by 2. Copy and paste it all the way down. And our closing balance is already doing it correctly. What we then want to do is work out our annual expenses. Now, annual expenses, only when we're in retirement must we worry about it. So we're going to come here and build the formula here first. So what we're going to say is equals if. So we're going to click on this cell here and say, is that cell bigger than 0? So it'll only happen when we're in retirement. If it is, take whatever is in there, multiply it with what we think we actually need, given that we're now retired. Otherwise, put 0. So what you'll see, that's adding, which is not what we want, because these are expenses. So I'm just going to put a negative sign in front there. So that looks like it's working. I'm just going to go one up. That looks fine. One down. That looks fine. So I'm then going to place it in here. So now what we've got is, while we're working, we don't take it into account. But once we retire, we look at our savings, we get our investment income, and then we spend money out of it, which then gives us a closing balance. Now that we know all of this, you can see we've got a potential problem. This amount of savings is a little bit short. We eventually go negative. So what we want to now work out is what should we have saved. So you'll see we've set up this section. There's a retirement calculate timing. So when are we retired or when are we dead? So you'll see we need to fund all those. All this is doing is pulling through how much we need, and we've just shown it as a positive number. So how much do we require at this point in time? So first I'm going to build it here, then we'll allow for the flexibility. So I know that if I need to fund all of these and I've got a return of 10%, I can use a net present value. What is the net present value of all these outflows? How much do I need at 10% so that in the end we're at 0? So this is a straightforward NPV calc. The rate is the rate we would earn. So I'm going to click on there and put my dollar signs in. The value, it must look from here to the end. And because we can let it continue like at that size, but I'm going to just put dollar signs on the last part so that it's from wherever you are to the end. When I say OK, you'll see it gives me 37,239. So where we actually have 26 million, we need to have 37 million. So this is fine, except every time I copy it, it's then going to go and assume the full calculation. We don't want that. We want it to only appear here. So we're going to build an if function around it. And the function is going to be something like this. If and that equals 0 and that equals 1, close bracket. So only at that point, only where you see that we weren't retired and now we're retired, That's the only point you do your NPV. Otherwise, just put a 0 there. Let's go one up. That's great. One down. That looks like it's working. I can now paste it in. So what you'll see now is it's telling us we should have had 37 million. Just that it's in a single cell and we don't have to search for it. Over here we've put a sum, so it adds it all up. We've got lots of zeros, and then at that one point the number. And now this has been built for you already. That's telling us what we should have had. This is telling us what we do have over here, and that tells us how short we are.